So, again a picture is worth 1,000 words. So, just like we did with the linear 2 port, we would like to show the performance of the 2 port in a picture. So, again we cannot draw a 3D surface. So, we will draw the input characteristics, which are again I1 versus V1 for different values of V2. So, what comment can you make? How will this look like in general? It will be non-linear. So, I do not know, something like that. Let us say this is the curve for V2 equal to 0, all right. So, for V2 is some of the voltage, let us say for V2 equal to some small delta V, what comment can we make? You will get another curve. Will that curve necessarily be parallel to this red line? No, it will be some other curve like that. Okay. And so, and what constitutes the operating point? What do we mean by the operating point? So, the operating point is V1 comma V2. In the case of a nonlinear 2 terminal element, the operating point was simply either the voltage or the current, because once you know one, you know the other. Now, you need to know both quantities V1 and V2. So, that is the operating point. So, on this picture, for example, this is your let us say this is your operating point. So, what is y11 now? What is the incremental y11 at that operating point? The slope, remember that the incremental y11 is nothing but dou f by dou V1 for what are we doing? Remember, what is in the linear network, what was y11? In a linear network, what is y11? Yes, you? Okay. So, mathematically what is it? I1 by V1 when V2 is 0, that was what we had in the linear case, right. Okay. When the network is non-linear, we can only talk about the incremental admittance parameters. So, what is the incremental y11? What should you say? I mean, in the linear case, it was the ratio of the output input current to input voltage when the output voltage was 0. So, when we talk about incremental quantities, what should we say? Ratio of the incremental y11 is the ratio of the change in the input current or the incremental current in port 1 to the incremental voltage in applied across port 1 when the incremental output is 0. Okay. It is not when the output is shorted. Okay. What would be the absolute voltage at the output port? It would be capital V2, right. So, we will establish the operating point by applying a voltage of capital V1 at port 1 and capital V2 at port 2 to find the incremental y11. We will make sure that the incremental change in V2 is 0, right. That basically and how do we make sure that the incremental voltage at port 2 is 0? We just keep a voltage source between the terminals of port 2. We know that a voltage source for incremental changes behaves like a short circuit. Okay. and then we will change V1 by a small amount, and we will see we will measure the change in the current in the input port and find the ratio of the change in the input current to the change in the input voltage. Is this clear? Okay. Now, look at this picture and tell me at the operating, let us assume that this delta V is very small. Okay. So, look at this picture and tell me how will I find the y11 at that operating point. What should I do? Yeah. So, in that picture, what is y11? Pardon? The slope at this point is y1. Okay. Now, what how will I what other information can I get from these two pictures at that operating point? Pardon? Okay. How can I get y12? Yeah, very good. So, basically what he is suggesting is that at this operating point, we know that V2 is changed by a small amount, and therefore, what does this quantity, what does that indicate? No, what does that spacing indicate? Y12 into delta V. Okay. And you can see that this is exactly analogous to what we did in the linear case. Okay. Now, if I draw another curve for V2 equal to 2 delta V, what comment can we make? Where delta V is still very small, what comment can we make? Will the curve be parallel, or it will not necessarily be parallel? So, you can get another curve like this. Okay. But what comment, if delta V is a small signal, indeed qualifies to be a small signal, what comment can we make about that that difference? It will be the same as the one before, assuming that delta V is a small signal, that will also be y12 times delta V. Okay. But in general, the curves will not be parallel. Is this clear? All right. So, similarly, the output characteristics, where we plot I2 versus V2 will follow a similar trend. So, these are the input characteristics, and these are the output characteristics. All right. And this will be some curve like that, right. So, this, for example, let us say this is for V1 equal to 0, and for some other, say V1 equal to delta V, it will be another curve, and say for V1 equal to 2 delta V, it is yet another curve, and for this operating point V2 comma, what is the operating point of the device? What is V1? This is the operating point. So, 0 comma V2. All right. So, what is Y22 now? It is the slope around the operating point. So, that is Y22. What does that distance represent, Revant? Y21 into delta V, and because delta V appears to be a small signal, that spacing at that operating point will be exactly the same or very close to what it was before. So, that is also y21 delta. Is this clear, people? Okay. All right. So, the next thing that I would like to draw your attention to is the notion of what a passive element is, right. When we looked at a two terminal element, we said that for a two terminal element to be passive, the product of voltage and current must be always greater than or equal to 0, correct. Now, what comment can we make? Now, we have a two port, what comment can we make? So, basically in the plus V2 I2 must be greater than or equal to 0 if the device is going to be, if the nonlinear two port is going to be passive. Is this clear? Okay. Now, under the special condition that I1 equal to 0, correct. If for example, we had a two port where the input current was 0, right. What comment can we make about passivity therefore? Then V2 times I2 must be greater than or equal to 0. So, therefore, what comment can we make about the output characteristics under these circumstances? The output characteristics must lie in the okay. This is one example, this is another example. Okay. Anything is possible as long as they lie in the first and third quadrant. Okay, this is just an example. Is this clear, folks? All right. So, that is all the background we needed to get started on our main quest, and namely we want to build an amplifier. And what is an amplifier? Well, we have an input source which is a small signal, all right, and we have a load RL and some voltage across it, and we have a box in the middle, and for argument's sake the simplest case of the box is that it is a two port. I mean, the box is evidently a two port because it has got an input port and output port. However, the box in the simplest case is a three terminal two port. So, the there is basically one terminal common between the input and output, and we connect it like this to the output. Okay. And what we are interested in figuring out is what should be there in this box, so that this whole system is an amplifier. What do we understand by an amplifier? Output power should be greater than input power. The fact that the output voltage is greater than the input voltage is irrelevant, right, because what we need is power gain, correct. So, for example, you can't put a transformer inside the box and then say it is amplifying. Even though you get a large voltage, the amount of power, the moment you put a load resistance, the voltage will drop dramatically, so that the total power can only be smaller than what is being sucked out of the source. All right. Okay. So, the question is, what must go into this box to make this an amplifier? The first thing is say, well, let us try this out using a linear network, correct. So, option 1, linear passive network. Is this a possibility? Linear passive network, basically, inside what it means is that you have resistors inside. Can we get power gain? No. Why? Well, whatever power is drawn from the source, some of it has to be dissipated in the box, and therefore the power coming out has to be smaller than what is being drawn from the source. So, therefore, this is a non-starter, very clear, right, because there is no source of energy at all anywhere. Okay. All right, then I say, well, this is very clearly a non-starter. Then what I am going to say is, okay, I can see that this cannot satisfy, I mean, this does not satisfy, I mean, evidently you can't get more energy in RL from that compared to that drawn from Vi. Is that clear? Okay. So, then I will say, okay, well, I am going to add up energy, since you said that this is not possible because there is no energy source. I am going to add energy sources. In the most general case, I will add one battery at the input, one battery at the output. I mean, if you say I am only going to put energy at the input, that is easy, we can just simply set V2 to 0, or if you are only interested in putting energy at the output port, you can set V1 to 0, but this is the generic case. All right. Okay. Now, what comment can we make for the voltage across RL? Can this option 2, linear passive network, plus 2 sources of energy, of power, energy, whatever. Okay. I have added voltage sources, but it could as well be current sources, it does not matter. Okay. Can some, I mean, now we have potentially, I mean, the power dissipated in RL can now be greater than the power dissipated in the power drawn from the input source. So, do you think we can, I mean, this is an option that will work? It depends on what all voltages, what can you write the output voltage, the voltage across the load resistance can be written as a linear combination of K1 V1 Vi plus K2 times capital V1 plus K3 times capital V2, correct, just by superposition. All right. So, so what, therefore, in general, therefore, what comment can you make about the power dissipated in RL? Can it be greater than the power drawn from Vi? It can be, right, but all that power is basically due to what? It is due to V1 and V2, that is not what we are interested in, correct. We want that component, the power dissipated due to Vi to be more than the signal power drawn from Vi. Does it make sense, right? The other, these components only contribute to they just contribute to Joule heating by simply burning DC power in the load resistor. Is this clear? So, by adding V1 and V2 which are external power sources, it is indeed true that the power dissipated in RL can be greater than the power drawn from Vi. However, most of that power is wasted power, right, because it is due to the DC sources V1 and V2, right. The signal component of the power, finally we are interested in making the power corresponding to the input voltage source Vi, right, more than the input power drawn from Vi. Okay. That still is very similar to what, I mean, is exactly the same as the initial option 1 where we did not have the 2 DC voltage sources. Does it make sense? Okay. So, basically this also, I hope all of you are convinced that this does not work, all right. So, what is the next option? This box must be non-linear, and passive. Will that work? Yes, what do you think? No, why? Why it won't work? Why? Exactly, right. So, it does not matter whether that box is active or passive, I mean if linear or non-linear. Its passive basically means that some energy is going to be consumed. So, even if this box is non-linear, it will you will not be able to get any gain unless there is. So, the only other choice we have is 2 sources of power. We still do not know if this will work, but at least this has a we have to investigate. Does it make sense? Okay. So, this therefore has to be a non-linear 2 port. Okay. The moment we talk of a non-linear 2 port, we can only talk of incremental gain, correct. Okay. So, we want the output, the voltage across RL to be a linear function of Vi. So, that basically means Vi must be a small signal, right, and therefore, so if we want the voltage across RL to be a linear function of Vi. So, we have to find the incremental gain. So, how will we find the incremental gain between V1 and Vi and Vo? Replace, if you want to find incremental gain, you replace every nonlinear element in this network by its incremental model. And how will that look like? What happens to capital V1? Short circuit. So, basically what we end up therefore on the input side is Vi, Rs. What do we replace the 2 port with? It is a nonlinear 2 port. So, around the what is the operating point of the 2 port? It is not really V1 and V2, it is what comment can you make about the drop across RL and Rs? To find the operating point, what will you do to the small signals? To find this small operating point, what will you do? You disable all the small signals. So, when you do that, Vi will become 0, there will be some current here, there will be some current there. So, what is the operating point of the nonlinear 2 port? Capital V1 minus capital I1 times Rs and capital V2 minus capital I2 times RL. So, there is some operating point. Around the operating point, what should you do? You replace this stuff by its incremental. Okay. So, we will do it tomorrow.